May Lunchbox session. Apologies, my camera is not on today, not working properly, but we have a very interesting Lunchbox session based on LNG methane emissions. So the Australian Gas Industry Trust engaged CSIRO, and more specifically Charles Heath and Cindy Ong, who both sit in Perth, to do this work. So I will pass it over to you. Ready whenever you are, Charles.
Thank you very much. I'm just going to share my screen. Okay. Okay. Can you guys see that?
Yes.
Okay, let's get started. Okay, so this is the basically the title slide. So this study was on greenhouse gas emissions from the LNG industry, and this is about a year old now. So there have been some changes in the policies since then, but still, this is basically a snapshot from about a year and a half ago. So these are some updated figures. So basically, by way of background, the LNG industry is obviously a very significant industry in Australia. So this graph on the left-hand side shows the volume and the value of LNG exports over time and also into the future. And you can see there was a significant increase during the 2010s, and we've now hit around 80 million tonnes per year of LNG exports, and that is approximately $90 billion worth, I think just last year, partly due to the high prices after the Ukraine war. So obviously the export of LNG contributes significantly. It helps our current account balance. And so the graph on the right just shows that LNG is basically second only to iron ore in terms of dollar value of our exports. However, natural gas is also, the combustion of natural gas also generates greenhouse gases. So we need to understand how that's going to play out into the quest for net zero emissions. So these figures here basically show that despite the push for net zero emissions, the demand for natural gas and LNG is going to continue for a significant period of time, up to 2040, these graphs go to. So the graph on the left-hand side shows basically the demand for LNG and gas, basically for different types of scenarios, for different pathways to net zero emissions. But you can see for all of them, there's significant demand that goes out to 2040. The graph in the middle basically shows the gas demand by sector in 2040. So it's mostly coming from electricity demand, but also a significant industry component as well. So in doing this study, we've based
emails while I listen to one of these Lunchbox things.
Sorry?
Yeah. If everyone can just go on mute, that would be really handy. Thanks.
Sorry. But yeah, so basically for this study, we've collected data from the National Greenhouse Gas Reporting Scheme and the Clean Energy Regulator. There's also information in company reports, the Australian Greenhouse Gas Emissions System, Information System, and the Department of Industry and Science and Energy Resources reports. However, there hasn't been a single document that's pulled together all the available data into a collated piece of information. There is also greenhouse gas intensity data, so emissions intensity data in a variety of sources, such as publications and government reports. So basically the idea of this study was to pull together all available information to understand what is the emissions profile of LNG. So the scope of the project was basically, there was a few different components to it. So we were going to provide a summary of the Australian government related environmental policies related to the LNG industry, a summary of Australia's greenhouse gas reporting requirements in the context of other countries as well, the Scope 1 and Scope 2 greenhouse gas emissions of the Australian LNG export industry based on publicly available data, And also Australian greenhouse gas emissions intensities for LNG across the 4 stages of the production chain. So that's upstream, the production or the liquefaction plant itself, shipping, and also end use. And we were also going to investigate how Australian LNG compares with international LNG in terms of its emission intensities. And also we explored what are the current trends in terms of industry initiatives to reduce emissions over time. So this is just a simple illustration of how the LNG works, the LNG industry works. So you basically have wells that produce the gas, and then there's pipelines, and then there's usually some processing that's done here that's not shown. And then the liquefaction plant where the gas is liquefied, it's then exported on specialist ships to the final customers where it's regasified and then sent by pipeline to customers where it's typically combusted as an energy source. So the map on the right-hand side shows the different projects around Australia. So you can see there's a significant number of projects in Western Australia. So there's 4 off the Northwest Shelf and Barrow. Oops, sorry. There's also the Shell's floating Prelude LNG project. There's 2 up in Darwin, so Darwin LNG and the Ithacus project. And there's 3 LNG plants on Curtis Island that take their gas from the coal seam gas fields in the Surat and Bowen basins. So there's basically 2 types of LNG production in Australia. There's coal seam gas LNG, and then there's offshore conventional LNG. So with coal seam gas LNG, basically the upstream flow looks like the diagram on the left. You have a large number of wells, typically thousands, that basically intersect coal seams at fairly shallow depth. These then gather gas, and then there's usually a fairly large number of small facilities like nodal compression facilities and gas treatment plants before the gas arrives at the liquefaction plant. There's also water treatment facilities. So you basically have a large number of small facilities upstream of the plant. There's quite often different corporate entities that are operating different aspects of that. There's quite a significant use of grid electricity, so we expect to see some Scope 2 emissions. And also some of the gas is sold domestically before it gets to the LNG plant. So for the offshore derived LNG, typically there are fewer but larger facilities offshore. There's usually a single company that is responsible for operating basically the upstream and the downstream parts of the value chain. They don't usually use any grid power, right? So we don't really expect to see much Scope 2 emissions, and they also produce other products, like they produce domestic gas, condensate, and LPG. There is also a smaller domestic LNG industry in Australia. So there's, I think, currently 6 small-scale domestic LNG plants that produce between 50 to 250 tonnes per day. So these basically take gas from a local pipeline or through some other arrangement with a local producer of gas, and they liquefy the gas, and then it's sent by road tanker, quite often to remote mine sites as an alternative to diesel. But because these plants are fairly small, they're below the reporting limits for greenhouse gas emissions, so we weren't able to get any data on these plants. So basically, for this study, the greenhouse gases that are reported are CO2, methane, and nitrous oxide for LNG, and these are reported as CO2 equivalent. And CO2 equivalent is basically the tons of whichever gas multiplied by its greenhouse gas warming potential. So we've covered Scope 1 emissions, which are direct emissions from a particular facility, and Scope 2 emissions, which are indirect emissions, typically from purchasing electricity, and it's the emissions related to the generation of purchased electricity. So Australia's greenhouse gas policy and regulatory framework. So at a high level, Australia is signatory to the United Nations Convention on Climate Change. And as part of that, in 2015, Australia signed the Paris Agreement, which basically aims to limit the increase in global average temperatures to below 2 degrees and to pursue efforts to limit to 1.5 degrees. And as part of that, Australia is also committed to net zero emissions by 2050. And basically, after we finish this study, it's now been updated to include net zero emissions reduced by 43% by 2030. So there's a couple of federal government policies that the government is using to pursue those targets. So one of those is the framework around Australian carbon credit units, which is done under the Carbon Farming Act 2011. So under this framework, companies or organisations that basically have projects that reduce emissions can generate Australian carbon credit units, and I think in some cases these can be sold to the government. So it's basically an incentive scheme, and then also other companies can basically purchase these units to offset their emissions. So they also have the safeguard mechanism, which is regulated under the Greenhouse Gas Energy Reporting Act. So under this act, facilities that produce over 100,000 tonnes of CO2 equivalent per year must determine a baseline. And there's various ways that can be done, but basically they have to have a baseline. And if they go above that baseline, they're essentially penalised for it. And so now, recently, that the safeguard mechanism has been modified so that the baseline reduces over time. Other federal government policies are basically they are funding various research into abatement technologies or to reduce greenhouse gas emissions, such as carbon capture and storage, where CO2 is captured and stored underground. They're also developing a hydrogen industry, and they're developing a hydrogen guarantee of origin scheme or certification scheme. So the states that have LNG projects, they have a number of state government policies that affect the greenhouse gas emissions of these projects. So in Western Australia, the state government has signed up to net zero emissions by 2050. And probably the most relevant piece of policy is basically large projects like LNG projects have to be assessed under the Environmental Protection Act of 1986 by the WA EPA. And the WA EPA has put out a guidance note on what they expect to be in applications for large projects related to greenhouse gas emissions. So from now on, companies must submit a plan if it's above 100,000 tonnes of CO2 equivalent, explaining how they're going to basically reduce their emissions over time. The Northern Territory government has also got a similar policy. So projects that require approval by the EPA and that are expected to produce over 100,000 tonnes per year of CO2 equivalent must submit a plan, including estimates of scope 1, 2, and 3 emissions, emissions targets and methods to show how those targets are going to be achieved. The Queensland government has also committed to net zero by 2050 and to reduce emissions by 30% below 2005 levels by 2030. So as far as I can tell, they don't have an equivalent policy yet, similar to WA and Northern Territory, but they do have a range of other legislation that regulates greenhouse gas emissions from the LNG industry. And so such as the requirement to do leak detection and repair programs that reduce fugitive emissions. So Australia's greenhouse gas reporting requirements for the LNG industry. So greenhouse gas reporting is done under the National Greenhouse Gas Energy and Reporting Scheme. So basically, corporations must register and start reporting once they hit a facility threshold, which is 25,000 tonnes or more of CO2 equivalent per year, scope 1 plus scope 2, or a corporate threshold, which is 50,000 tonnes per year. So they must report scope 1 and 2 greenhouse gas emissions, and they have to report basically these gases here. So CO2, methane, nitrous oxide, sulfur hexafluoride, and various other fluorocarbons such as refrigerant gases. So they only have to report if there's a method in the NGR determination for calculating the emissions, and the NGR determination has a large range of methods relevant to the gas industry, including methods for calculating fugitive emissions, wellheads, offshore platforms. They also have methods for calculating Scope 2 emissions due to purchased electricity. So by comparison, the United States also has quite a comprehensive reporting scheme. So their reporting scheme is done under the US EPA's Reporting Rule 40, which is Protection of the Environment, Part 98, which is greenhouse gas reporting. So this was introduced in 2009. So Australia was actually ahead of the United States. And their thresholds are similar. So facilities, they have a facility threshold of 25,000 tonnes or more CO2 equivalent per year, but most of their reporting is actually done at the facility level rather than at a corporate level. So the rules tend to be more segmented and sort of granulated by industry. So they have 41 separate industrial classes of emissions. The gases that must be reported are essentially the same. But the component which is most relevant to the gas industry is Part W, which is petroleum and natural gas systems. And this covers the entire production chain of LNG. And it contains methods, a very large array of methods, such as emissions for wells, greenhouse LNG processing, LNG liquefaction, that type of thing, similar to the Australian methods. So Qatar and Russia are also quite significant exporters of LNG. As far as I can tell, Qatar doesn't have a compulsory government greenhouse gas reporting scheme. Their legal framework is a bit different to Australia and the United States. So their energy companies are all 100% state-owned. Despite that, they actually do voluntarily report their Scope 1 and 2 emissions in their sustainability reports. So Russia, basically, they introduced a law, or their legislation. They introduced legislation back in 2021 that was due to basically force companies emitting over 150,000 tonnes per year to start reporting their emissions from 2023, and then that was going to come down in 2024 to 50,000 tonnes per year. And this was, I think, this was basically due to pressure from the European Union because they were purchasing a large amount of gas from Russia at the time. So I'm not sure if this is still going to go ahead, but they do have a law in place that requires greenhouse gas reporting. So basically, these are our summary numbers from Western Australian LNG projects for their Scope 1 and Scope 2 emissions. So most of most of this data has come from the Safeguard Mechanism Guide data, which is published on the Clean Energy Regulator's website. So this is all done on an operational control basis. So basically, the company that is the operator of the facility is essentially associated with 100% of their emissions, even though these are all mostly joint projects. We've also assumed that these projects operate for the main purpose of producing LNG, even though they do produce other products. We did attempt to apportion the emissions due to LNG, but because we were not able to obtain data, sufficient data, we basically assumed that these are all related to LNG production. So you can see that our Scope 2 emissions are about 20,566,000 tonnes. This is for 2019-20. Scope 2 emissions, we were not able to obtain data on the Scope 2 emissions that we could really apportion to these specific facilities or projects. However, we expect this to be very low because these projects all operate off-grid. For the Northern Territory, we obtained Scope 1 emissions data for Santos's Darwin LNG from the Safeguard Mechanism data. But for Impacts, we actually used their corporate data because Impacts doesn't operate any other projects, or they didn't at the time. We did actually include their Scope 2 emissions, so we can see that this is very low. This is probably not actually the LNG plant itself. This is probably some other related activities, but because Impacts only operates one project in Australia, we've basically associated this with LNG production. So for Queensland, we've separated the LNG production into two components. So this is the upstream, but we also have a downstream component. So the upstream gas that is used to produce LNG comes from a number of different companies. So for Origin, we've obtained their Scope 1 and Scope 2 emissions from their sustainability report. For QGC, we've obtained it from their corporate data due to QGC upstream investments, and we've subtracted their Scope 1 and Scope 2 emissions data of their Condamine power station out of it to get the emissions due to their gas production. For Santos, we couldn't get any data that we could really use that was specific to their coal seam gas production in Queensland. So we've used the production weighted average of Origin and QGC's data, where we've combined Scope 1 and Scope 2 because we weren't sure if they were using the same mixture of grid power as the other two companies. And for Westside, we've obtained that from their NGO corporate data. So the other thing we've done is, because we know that some of this gas is sold before it gets to the LNG plants, we've calculated the proportion of the gas that is produced using data from AMIO, using basically the pipeline flow data. So we know that 90% of the gas that is produced here is actually liquefied and exported. So once we take that into account, we have total Scope 1 emissions for the upstream component of about 2.5 million tonnes and about 4.2 million tonnes of Scope 2. So you can see that most of the emissions are now Scope 2 emissions. So for Queensland downstream, these are the three LNG plants on Curtis Island. So for the Asia Pacific LNG facility, this is operated by ConocoPhillips. So we've used their corporate level data, as they only have a single facility in Australia. And so you can see that there is actually some Scope 2 emissions from the Asia Pacific LNG plant, or at least they report 333 tonnes. So that may be actually some associated activity, but it is very low compared with their Scope 1 emissions. For Queensland Curtis LNG plant, we've obtained this from QGC's midstream investments corporate data, and they've actually reported 0 Scope 2 emission. And for the GLNG plant, which is operated by Santos, this is safeguard mechanism data. We couldn't get any Scope 2 emissions. So in total for Australia, we estimate there's about 37,500,000 tonnes of Scope 1 emissions and about 4.2 million tonnes of Scope 2 emissions due to the LNG industry in Australia. So this was 2019-20 data. Emissions intensity. So the Scope 1 and Scope 2 totals are useful in understanding the total emissions, but in order to really understand how LNG compares with other energy sources, or to compare Australian LNG with international energy, we have to really express it on a different units. So quite often it's done on a tonnes of CO2 equivalent per tonne of LNG basis, but kilograms of CO2 equivalent per gigajoule is actually more useful for comparing LNG with other energy sources. But we've actually included both in our study. These data is generally obtained from life cycle studies, so which basically assess the total emissions over the entire lifetime of a product related to production, shipping, and final use. So we have reviewed life cycle studies of Australian LNG and categorised the emissions into an upstream component, which is wells, compressor stations, processing plants, also the liquefaction plant itself, shipping, and also end use. So these are the studies that we could find that relate to Queensland LNG. So this only includes upstream liquefaction and shipping. The final use, which is the highest emissions category, we're going to put that in a separate category because a lot of these studies don't actually include that. So you can see there was a few early studies that were done up to about 2012. So some of these were fairly early studies. Some of them didn't use specific data due to projects. They basically used models or assumed values, and they tend to have fairly high numbers. Probably the best study that we could find for Queensland was the study by a CSIRO team in 2019, this one here, Shandel et al. And they basically arrived at a number of about 11.23 kilograms of CO2 equivalent per gigajoule. And you can see there's also another study in 2019, Gan et al. 2020. And they have slightly higher numbers. So this study, they've used modeled input parameters. However, they did a lot of different projects from around the world. So it's quite useful for a comparison perspective. But probably the best numbers that we have are from the 2019 study by Shan et al. For Queensland. So for Western Australia, again, there's a couple of early studies. So these of the Barnett one didn't actually include upstream, and there's one in 2013 which was an early study as well. So probably there's a couple of more recent studies. So Gan et al. So they've done their study on a per field basis rather than a liquefaction plant basis. So for LNG from the Gorgon field, they've arrived at quite a high number, which is 29.67 kilograms of CO2 equivalent per gigajoule. However, this is based on the assumption that all of the CO2 from the feed gas was just going to be vented, because at the time the CO2 injection on Barrow Island was delayed. However, that has now started, so this number is probably outdated. The Janslow field, however, shouldn't be affected by that, and so this number here is probably okay. However, there's a great deal of variation between studies. There's another study that was done by McConnell and Grant by Woodside. So it was these are consultants. It was funded by Woodside, and for the Scarborough project, and they've arrived at much lower numbers. So the Scarborough project has quite low CO2 in its feed gas. So for this study, Woodside basically gave the authors specific proprietary data. So they had access to a much better data set. They also had much lower shipping emissions. And again, this is because they had access to specific data from Woodside. So they've arrived at a much lower figure. So that's actually quite promising that these emissions may be lower than some of these other studies report. So for the Northern Territory, there's very few studies that have been done, really. The only one that we could find was in 2010 by Barnett, and he didn't include any upstream component, and he's just used basically modeled figures rather than proprietary data. So there's essentially a big gap in our understanding of what are the emissions intensities for Northern Territory LNG. So the other place that you can obtain emissions intensity data is from company sustainability reports. So this is what the graph on the left shows. So this is a little bit different to life cycle study data, in that essentially the data is calculated by taking the total production from the LNG plant and then dividing the greenhouse gas emissions, the Scope 1 greenhouse gas emissions, by the total production in each year. So you can see that the LNG plants that have been running for quite a while are quite stable. However, you can see that for Gorgon, there was quite a significant decrease during commissioning. And so this source of data is valuable because it's available more readily than our life cycle studies. So you can see trends over time. However, if you were going to compare these numbers here with the life cycle studies, you'd only want to compare it with the LNG plant itself. So you can see that the emissions intensity here is about 0.3 to 0.4 generally, tons per ton. And for the liquefaction plants, we have numbers of around that order of magnitude for the liquefaction plant in tons per ton. So the number in bracket is tons per ton, basically. And despite the fact that these are using very different techniques, right? So the life cycle study method will generally include other things as well. So the numbers actually do add up pretty well. Combustion. So for final combustion, there's various different numbers that are available. Probably the two best ones we could find were either the NGR method determination. There's a figure in there that basically allows for a calculation of emissions from fuel, right? And that's 51.53 kilograms per gigajoule. So the other alternative is a final use, is a combustion number from Shandot et al. And that's much higher, well, a bit higher, 64.4 kilograms per gigajoule. And that's, they basically state that this is due to their life cycle approach, and they've included some other categories into that figure as well. So we also have some numbers for regasification. They're generally quite low, around 0.4 to 2 kilograms per gigajoule. So for emissions intensities, comparing Australian LNG with international LNG, so this figure here shows how Australian projects relate to international projects. So this figure uses data from various places. So a lot of these come from Gan et al. Because he basically did so many different projects. The number 8, Australian WA Scarborough, is the study that was funded by Woodside, by McConnell Grant, and number 7 is Australian. That's basically the 2019 by CSIRO study, and the rest of them are from Gan et al. So you can see that Australian LNG sits definitely in the lower section of the graph. There's a bit of variation, obviously, between different projects. However, the top end of the curve is really dominated by gas from the United States, LNG from the United States. A lot of their gas comes from unconventional sources, and they tend to have very high upstream emissions. So you can see that their upstream emissions are very high. The other thing is that all these studies here assume shipping to China. So the United States is just further away from China, so their shipping emissions are also higher. So you can see that Australia ranks fairly nicely compared with international sources for LNG. So we've also looked at industry efforts to reduce emissions over time. So one of the biggest one that is being done is CCS, or carbon capture and storage. And so the figure on the right-hand side shows roughly how that is done. So this is basically for the Gorgon project. So basically the CO2 is separated from the gas, and then it's injected underground into geological formations. And so this is currently being done on Barrow Island to store CO2 and to reduce emissions from the Gorgon project. And it will store up to 4 million tonnes of CO2 per year. So Santos has also made an FID on the Moomba CCS project, and they're currently working on that. I've actually seen the wells that they've drilled. INPEX is also committed to invest in a CCS hub in Darwin. And there is also a wide range of other efforts, such as emissions offsets. So emissions offsets are being used by various industry players to reduce their emissions. And these are generally done by either generating or purchasing Australian carbon credit units or international carbon credit units. So Woodside is using this approach to offset their emissions from the Pluto LNG project. They have basically carbon fibre projects around Australia where they've planted trees, and they're also purchasing offsets from overseas. And there's also the West Arnhem Land Fire Abatement Project, where basically Indigenous rangers carry out strategic burning in the cooler part of the year, and this reduces emissions from really intense fires later on. And so some of these ACCUs have been sold to the Darwin LNG joint venture in recent years. So there's also efforts to reduce fugitive emissions from leak detection and repair programs, which is basically inspections of basically pipe flanges and valves. There's also been a number of efficiency improvement projects recently to reduce basically fuel usage on offshore platforms. There's also investment. Most companies are investing in hydrogen as a future low emissions fuel. There's also development around cargoes of LNG being certified as low emissions. So there's been a number of cargoes of LNG that have basically they come with a certification that basically the production of that LNG is zero emissions, and this is done using offsets typically. But this is still a developing area. So in conclusion, Australia has committed to net zero by 2050, and there's a range of policies that are being used to regulate emissions at a state and federal level, such as the safeguard mechanism and project approval processes. There's a pretty comprehensive greenhouse gas reporting scheme in Australia, which is comparable to the United States EPA reporting scheme. We estimate that the Australian LNG industry related to the export was 37,519,000 tonnes in 2019 of scope 1, and scope 2 was 4,232,000 tonnes. Basically, emissions intensities from life cycle studies, they vary widely depending upon the project and the methods that were used in the study. But probably one of the best ones we could find was the study done by the team at CSIRO in 2019, which gave a non-end use figure of 11.23 kilograms per gigajoule, or 0.611 tonnes per tonne of basically. And so for other states, the non-end use emissions are basically from 7.06 from the Connell grant to 17.49, which was from Gan et al. The final use emissions are the best number we could find, or the most comprehensive number we could find, was 64.4 kilograms per gigajoule. And there are a range of industry efforts underway to reduce emissions towards net zero, including CCS, the use of offsets, efficiency improvements, and developing hydrogen. Okay, well, thank you very much. It's been a pleasure. Is there any questions? I'm going to stop sharing, or at least.
Any questions from the floor? I've got one.
Yeah.
Charles, you started to touch on the fact that when you compared our work to, like, in terms of emissions reduction in the US to us, are we by any chance looking better than they are, or are they kind of leading the race?
As far as I can tell, there's not a huge difference as far as I can tell. Like I think a lot of their stuff is unconventional, and so it probably looks a bit different to our efforts. I think our efforts are mostly CCS. I think they have a lot of work to do on reducing their fugitive emissions from their basically unconventional gas industry. Yeah, I would say that we're doing pretty well, but I mean the Americans are pretty active, you know.
Yeah. And my last question was about the reporting. There are obviously holes in the data just because the lack of availability of the data. As that becomes more compulsory, according to regulation set out mostly by the feds and state governments, obviously this will get a lot better, but are you seeing it that sort of reporting coming forward in any sort of near or medium term future?
Well, the companies do actually have to report quite a lot of data. It's just that a lot of it's not actually available, publicly available on the Clean Energy Regulator's website. So hard to say, really. You know, that there is actually a lot of data that they do report. They reported much more detailed data than is available. So it depends on what the government wants to do. I don't know what the Labor government will do. They've already updated various things recently, so there hasn't been any change in the data that's actually publicly available online.
Yeah. Okay, thank you very much. Any other questions from the floor? Okay, I think I'd say that's it. Charles and Cindy, thank you so much for your time. Thank you so much for the report. The report is up on the AGIT website. If you slide straight to the bottom, look on the right, it should be the one on the top of the list because I put it up there this morning. This will also be available on our AGIT YouTube channel for anybody who wants to watch this going forward. And the last thing I was just going to say was the International Gas Union, its research conference, it's called the IGRC, is being held in May in Canada in 2024. One of the key streams is around methane emissions reduction, and they've just this week put out a call for papers. So if anybody is interested, let me know. If anybody wants more information, it's up on the AGIT LinkedIn page. I put it up there this morning, so please have a look. And I'd say that's it, folks.
Okay.
Charles, Cindy, everybody online, thank you so much. And I'll see you at the next one. Bye.
Thank
Bye,
you.
everyone.
Thank you.
Okay.
Thanks.
Thank you.
Bye-bye.
Thank you.
Bye.
See you later. Bye.
All right.
Bye.